So today we are going to start with our new chapter, vector algebra. This is your chapter number 10. So let's start with vectors. What do you mean by scalar and vector quantity? So it's a scalar quantity which you have already read in class 9th. A quantity which have only magnitude, which is a real number, such quantities are called scalar quantities. Example, length, mass, time, distance, area, in which we only have some real value, but we do not know in which direction it is going. And what is the difference? See the vector quantity. A quantity that has magnitude as well as direction is called a vector. And we denote it because direction is given. So if we have to denote this vector, just see a diagram you can see over here. A and B, and it is represented by a small a with an arrow on the head of this A. So a vector is always represented with an arrow above whatever it is given. It's given AB, it's given with small a, whatever it is given, it is represented like that. So where A will be the initial point and B will be the terminal point, you can say, or final point, you can say. The distance between initial and terminal point of a vector is called the magnitude of the vector, denoted by this modulus. We put it over here, which denotes the magnitude of that vector. The arrow indicates the direction of that vector. Since the length is never negative, the notation of magnitude of the vector is less than 0 has no meaning. Since magnitude means the distance between A and B, so it will be always with a positive number, any positive real number. Now let us understand about position vector. Just see, you can see here the diagram. It's a three-dimensional figure, but it is drawn here on this. So if a point P is there, it will have the coordinates X, Y, and Z. And this is the origin O with 0, 0, 0. So we are telling here what is the position vector of point P. This is a point P in the space having coordinates X, Y, Z with respect to the origin 0, 0, 0. This vector OP, where O is the initial position and P is the terminal position, and the value of OP means the magnitude of OP, which we are representing here with small r also, is given by the distance formula. Already we have done distance formula in 3D in class 11th. Using that, we are getting here under root of x square plus y square plus z square. In practice, the position vector of point A, B, C, etc. with respect to the origin are denoted by A, B, and C. See here, another diagram you can see here, small a, small b, and small c. If the position vector of point A we need, this is represented by small a, similarly small b and small c. Now let's move to another topic that is known as direction cosines. Now these axes, this x, y, and z axis are 90 degree, are at 90 degree with each other. Now a point is P which having the coordinates x, y, z is in the space. This P point, this OP, which is denoted by R, is making angle of alpha, beta, and gamma with the x-axis, y-axis, and z-axis. You can see here, it is being shown, tried to be, it is a 2D figure, but we are trying to show here in a 3D figure. So you can see here, POA, you can see with an angle alpha, then an angle beta is there with y-axis, and this is angle gamma. These are known as the direction angles because they are made with the direction axis. The cosine values of these angles means if we consider cos alpha, then cos beta and cos gamma are called the direction cosines of the vector r, and they are also denoted by small l, small m, and small n respectively. Now let us find the values of these l, m, n, or you can say cos alpha, cos beta, cos gamma using this position vector, position value of xyz with respect to 0, 0, 0. You can see another figure over here. We had just taken out this triangle OAP and we are showing it here separately that at A point, it is making 90-degree angle and this is your angle alpha. So from here, if we consider using trigo, cos alpha is equal to base upon hypotenuse. So it is x upon r, means cos alpha is equal to x upon r. Similarly, if we'll take the triangle OPB, we will have cos beta is equal to y upon r. And the third triangle, if we'll be taking the, it will get us cos gamma is equal to z upon r. In place of cos alpha, cos beta and cos gamma, we can write L, M and N, which will give us x is equal to LR, y is equal to MR and z is equal to NR. These LR, MR and NR are proportional to the direction cosines are known as the direction ratios, denoted by small a, small b and small c. These direction cosines are always proportional to the direction ratios, which are given represented by small a, small b and small c. See here, L square plus n square plus n square is equal to 1, means the sum of the squares of the direction cosines is equal to 1, but this do not hold for direction ratios. You have to keep in mind this note. This is a very important point from which one marker questions can be made. Now see, there are various kinds of vectors. First is the zero vector. Zero vector, from the name itself, it shows that it is having no value. Means where the initial position and the final position is just the same. Or you can say AA vector or BB vector, means no magnitude will be there and no direction will also be there. So it is a zero vector. Then moving to unit vector. Unit means 1. A vector whose magnitude is unity. Unity means 1 is called a unit vector. The unit vector in the direction of a given vector A is denoted by A to the A. You can see a cap is there on A, which is denoting its unit vector. Then moving to co-initial vectors. Two or more vectors having the same initial point are called co-initial vectors. Means their initial points are same, they are starting from the same point. So we can, next is collinear vectors. Two or more vectors are said to be collinear if they are parallel to the same line, irrespective of their magnitude and direction. Means their magnitude can be anything, but they should be parallel to the same line. Next is equal vectors. Two vectors A and B are said to be equal if they have the same magnitude and direction regardless of their position. Means they can be anywhere at any place, but they should have the same magnitude as well as the direction. Then they are known as the equal vectors. Then moving to the next topic, negative of a vector. A vector whose magnitude is the same as that of the given vector, but the direction is that opposite to it, is known as the negative of that given vector, and it is represented by, suppose the negative of BA we need, it will be given by minus AB. So the vectors above defined are such that any of them may be subject to its parallel displacement without changing its magnitude and direction. So in this chapter, we are going to read about these free vectors which can be moved from one place to another without changing its magnitude and direction. So these are known as the free vectors, and that only we are going to deal in this chapter. So let's do just a very small exercise of exercise 10.1. Here it is being told, represent graphically a displacement of 40 kilometer 30 degree east of north. So we know the where are the directions. This is 30 degree east of north. So this is point P. And this is 40 kilometer. Just it is represented. This is the question. Actually, these questions don't come in the exam, but it's given in the exercise, so we are doing. And here we have to classify which are the scalars and the vectors. This you have to do it on your own. 10 kg is scalar, 2 meter northwest. Whenever the direction is given, means it is vector. Like this is there. 20 meter per second square. It is a vector quantity as it involves magnitude as well as direction. And this is question number 4. We have to see by the diagram and the directions which vectors are co-initial vectors. Like see here, A and D having the initial point as the same, so they are co-initial vectors. Equal vectors means B and D are equal vectors because their magnitude is same as well as direction is also same. And the collinear vectors. Collinear vector is A and C because they are parallel vectors having a different direction, but they are parallel to each other. So this was the topic. Today I am finishing. This is your part 1, chapter 10. We'll be doing the next part tomorrow.